CEO Tesla at Tesla's Battery Day announcement 2 years ago. Elon Musk took the stage to introduce a revolutionary battery cell that was created to boost significantly range enable. Welcome back to another exciting video from PrompTech. Today's video is about Elon Musk and Tesla just announced huge problems with the 4680 battery. Before we start the video, please like, subscribe, and press the bell icon. Power hungry. New products such as semi-cargo vehicles and cyber pickup trucks cut production costs at a fraction of the cost of the 2170 battery. He listed attributes such as a high nickel cathode, silicon anode, and an innovative packaging technique. But so far, it has only affected one of these alleged properties. Now issues with the 4680 are approaching. What problems have Tesla and Musk been trying to solve with their 4680 batteries? Stay tuned because the answers may surprise you. Tesla is still in the early phases of its production ramp, despite Musk's 2020 promise that the company would build enough new batteries to power 1 million or more vehicles this year. The difficulties of opening new factory. Even though Musk is notorious for achieving the seemingly impossible, developing a new technique of battery manufacturing is perhaps too much. He started by making the maker of electric vehicles the most valuable automaker worldwide. Recently, Elon Musk celebrated Tesla's first quarterly profit of $1 billion. Its successful seventh quarter restates the lingering worry of impending corporate insolvency. However, on Tesla's earnings call for the second quarter, he also made known something that was typically ignored. He was stuck with two of his most beloved new inventions. These initiatives, coupled with others he outlined last fall during his Battery Day event, could reduce the cost of electric vehicle batteries to $25,000 and enable mass manufacture. 10% of the planned savings was lowered due to the new problems Musk outlined. Battery cost. It will be severely put off and might never happen. Musk's Cybertruck launch may also be delayed until next year, placing it in direct competition with the electric version of Ford's F-150, the best-selling pickup in the world, which is also due to make its debut. He added that the long-distance Tesla Semi's debut has already been postponed. Musk may have been able to keep his word while arriving late with no consequence. But this time, there will be genuine rivalry, and interest in EVs produced by businesses other than Tesla has increased dramatically. The problems with the new battery, which he referred to as the 46, were recently made public. The world of batteries was interested in this massive cylindrical cell with dimensions of 46 mm by 80 mm. Considering the clever change, it suggests tradition. Lithium-ion. He refers to this idea as tablets, which entails not just enlarging the battery cells but also packing and rearranging how energy is discharged from the battery. These solutions can eliminate the costly modules and packaging that prevent the batteries from catching fire, while also removing the hazardous battery heat. Along with the other advances he outlined, Musk also touched on a fresh way to make the two electrodes that are the foundation of every battery during last fall's storm: dry electrode coating. Usually, a considerable quantity of slurry is made by mixing many electrode powders with water or another solvent. The slurry is then coated onto metal foil to generate an electron. However, the electrode must be dried in huge furnaces before removing the solvent. At Battery Day, Drew Bago, Musk's battery deputy, announced that the business would skip the oven and go from dry mix to coat, rather than going through the solvent stage. In their subsequent explanation, Bago and Musk discussed a coating technology that may reduce the plant size required to produce electrodes, the cost of batteries by around 10%, and the amount of energy needed to create batteries by the same amount. Even though they needed to work out a few glitches, the men insisted they were making progress. The lack of significance of dry coating was their second defense. Tesla's most significant obstacle was getting ready to offer a novel manufacturing technique called a dry electrode. The technology obtained when it purchased the California startup allowed for this approach. Maxwell Technologies. The fabrication of dry electrodes omits the traditionally difficult battery manufacturing stage, including a chemical slurry. Musk freely admits that it will be challenging, but if it succeeds, it will be more affordable and efficient. Lacking in dry coating still, the 4680 might be started. But if the electrodes themselves couldn't be created, that wouldn't be conceivable. And that was the other discovery Musk and Bago made. Do you remember how a slurry covered the metal foil sheets? The application of a smooth, uniform coating must follow a specific technique: calendering. To do this, massive rollers are used to compress coated foils. Musk asserted on the call that the slurry is run through these rollers and squished like tough pizza dough. Pizza makes. Like spreading out pizza dough, calendaring is a standard and easy phase in producing batteries that everyone takes for granted. Musk's analogy is thus appropriate. Calendaring is not, however, compatible with the 4680. Musk said that he and his team needed to prepare for it to dent the calendar rollers precisely. Musk was still determining if the problem would be rectified in time, despite Tesla having previously announced that the 4680 would be utilized for the updated version of the crossover Model Y later this year. We have a backup plan with a non-structural pack in 2170s. He said about using smaller batteries without cell-to-pack technology. The UV would not offer any of the financial reductions he claimed on Battery Day due to the backup plan. The announcement confused the small global community of battery experts who aren't used to calendaring problems. According to the rules of battery physics, the bigger the cell area, the more likely they are to be flawed. Additionally, bulky cathodes need more calendaring pressure to smooth and flatten their metal particles. Nickel, manganese, and were used in Tesla's case. In Lin's opinion, calendaring a nickel-cobalt-aluminum or 4680 nickel-manganese-cobalt cell results in a battlefield of crushed and shattered particles. Battery specialists believe Musk would eventually find a solution to the issue, but nobody could be confident because no one had ever commercially built an EV clinical battery that was as huge as Musk's, the 4680. Shortly, during the call, Baggo made it apparent that everyone was working toward Tesla's next battery. We already know that Tesla's existing battery packs, based on model numbers, are 4680, falling short of the company's claimed goal of a 50% cost reduction compared to current batteries. The vast majority of the cost savings can be attributed to the packaging efficiency of packing them into considerably larger tubes, which enhances volumetric density and decreases the requirement for welding spots. Tesla anticipates shortly performing a test run, although for the time being, the electrode's crucial dry coating process. This is still a pipe dream and does not call for poisonous mixtures or Doven baking. Additionally, independent 4680 battery teardowns and chemistry analyses reveal that Tesla continues to use conventional 811 nickel-manganese cobalt cathode compositions and regular graphite anodes. Even NIO, which is farther along in the development and mass production of a 150 kWh high-nickel battery, meant to power its top ET5 and ET7 performance set-in models for more than 620 miles on a charge, was compelled to postpone it. The first batch of 150 kWh semi-solid packs with high-nickel technology in mass production from the battery company on which we rely was planned for delivery in 2019. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.